Hello and welcome back to my humble little channel. So on the bench today we have a Kenwood TS 2000. Very nice radio, and it covers HF 6 meters, 2 meters and 70 centimeters, 100 watts on HF and 6 meters and 2 meters, and 50 watts on 70 centimeters. Now this radio has been out on loan to a friend for 2 years, but he didn't really want to buy it off me, so I've had it back now and I need to sell it, because this is the radio I used to use on 2 and 70. I never used it on HF, but then I bought the IC 9700 for 2 and 70, and so this was basically no longer used. That's why I lent it out. So now I need to sell it and move it on, but before I sell it, I really think it's a good idea to check it over thoroughly to make sure it's working to its specifications, because I don't like selling stuff that hasn't been checked thoroughly. So that's what I'm doing today, just checking its frequency accuracy, power output. That's about it really. There's not much else that needs to be checked. Maybe it's receiver sensitivity, but I'm sure that'll be fine. But the first check I'm going to do is the frequency accuracy, and he uses what's it called, a TCXO inside it, TCXO oscillator. So it should be fairly stable with temperature, but I don't know how accurate it is after probably 5 years since this was bought. But anyway, to do that, I'm going to be transmitting on the lowest power output, which is 5 watts, as low as it will go. But I can't plug that into my frequency counter, because that would be the end of the counter, in theory. Although it does say it's fused on this input. But in order to do this test, I need to put it through this device over here. And this is a 100 watt 30 dB power attenuator, which has got more or less flat response from DC to 2 gigahertz. So in theory then, if I put 5 watts into one end, I'll get 5 milliwatts at the other end. So let's go ahead and do the test. I thought for a change I'd use my old Dana counter, because that doesn't get used much these days. Bloody arm. Right, Dana counter. It keeps bloody sagging. Okay, that's stable enough. Now the Dana counter is a nice counter, but I normally use the HP because it's got better resolution. It's a much nicer frequency counter than the Dana, but I do like the red display on this one, and it's more than good enough for doing this test. And I'm feeding in a 10 megahertz reference at the back of it from a GPSDO, so I know it's going to be very accurate. So there we are. So I'll go into transmit on 2 meters on 145/500, and we'll see what we get on the counter. Okay, that's interesting, isn't it? It's quite clear that there is an error in that frequency reference in the radio. That's 292 hertz out. That's a fair bit of frequency error. Well, you wouldn't notice that on FM, but you certainly would notice that on single sideband. So it's not good enough, is it? So it needs adjustment. Just while we're here, we'll check it on 70 centimeters. So I'll stop transmitting, change the aerial over to the UHF output, and go up to 70. Now I've set to 433 megahertz and I'm going to transmit. I expect the error is going to be more now. Yeah, so there you go. It's a 331 hertz error. In other words, the oscillator in the radio is running low to create an error like that. So yeah, so this is quite clear. It needs a bit of adjustment. Before I do any other tests, I think really I ought to take the top off it and adjust the TCXO. And I think I'll have to find out what it is, so then I can get the counter onto the actual output of the oscillator rather than the output of the radio. So I'll get the lid off and then I'll do that. So it turns out the oscillator in it is on the bottom part of the radio, so it's quite hard to see, but it's right down there. Where is it? Yeah, down there. There's a little metal can there, and with an adjustment screw on it. So that's what I've got to adjust. And I've got to get a scope probe down here, zoom out a bit. The actual signal is on that white wire there. You can see that. I've got to try and get a scope probe into there without damaging anything. Okay, that's my scope probe attached. So if we got to the counter, it should be 15.6 megahertz. As you can see, it's not. So we've got to get a tiny little screwdriver down inside it and adjust it, which might be difficult because it's quite hard to see. And obviously I have adjusted it. Okay, so I need to get 15.6 exactly. Right, bit low. I think it varies a bit when you touch the actual screw. And of course you have to have your tongue at the right angle, as Dave would say. It's really critical. Of course my screwdriver keeps slipping out. It's very, very touchy, this adjustment. That's 3 hertz out. There, see, it's gone up to 10 hertz now, just with a minute bit of adjustment. It's unbelievably hard. It's just a fraction of a turn makes a massive difference. Close. I think I'm going to leave it there. That's 3 Hertz high, 2 Hertz high. It's so fine, the adjustment. I don't think I'm going to do better than that. 2 Hertz error. Okay, let's get the top back on it. So it's back together again, and I just wanted to check it again on 2 meters, the frequency transmitting. So it's now 16 Hertz out, so it's drifted that much just by whatever. So it's obviously not a particularly stable oscillator in there, but I think that's pretty good. 22 Hertz. It's not bad at all, and it will vary. Probably knock it and it will vary, but anyway, I think I've done as best I can on that. So next thing I want to do is check its power output on various frequencies, so I have to reconfigure everything for that. Okay, before I do the power check, I'm going to just check the receiver. At the moment I'm putting in a massively strong signal of minus 50 dBm, which equates to 700 microvolts. So that's a big signal. But if I lower that down, that's minus 60, 70, 80, minus 90, minus 100 dBm, minus 110, minus 120 dBm. So just about losing it. That's about minus 125 dBm. So I think that's pretty sensitive. Of course you can turn the preamp on and off, but it's just deaf as a post without the preamp. And so that equates to 0.12 microvolts of signal. But the only thing I don't like about this radio on FM is the dynamic range of the S meters, only about 20 dB from S1 to S9 plus 60. It's hopeless on FM, the S meter. It's okay on single sideband, but FM's crap. Could do 433 megahertz, so got to 433. Change the aerial, change the frequency, so that's 433, and it's about the same sensitivity. That's 0.12 microvolts. That's 0.1 microvolt, and you can just detect the signal still. I should be in narrow actually. Function. You get a better signal to noise ratio in narrow FM. So that's a pretty small signal, that's 0.1 microvolt. So I think that's a pretty decent sensitive receiver. Not going to check it on HF because it's not such an issue on HF to have high sensitivity, except possibly on 10 meters. So that's a good enough check for me. And next I'll do the power test. Okay, to do the power test now, and I'm using my HP RF power meter, which is very accurate. Well, fairly accurate. As accurate as you'll get with RF power. And in order to do this test, Not only do I need that 30 dB attenuator, I need another 10 dB on the other end. It's also a total of 40 dB, because I do not want to blow up my power sensor, which has got a maximum input of plus 20 dBm or 100 milliwatts. So okay, let's go up to the power meter. And I've got the power set on the radio to 5 watts. So if I go into transmit, how do I do that? That button there, 4.8 watts, that's fairly reasonable. You're not going to expect it to be highly accurate. That's 10 watts. I'll go up quickly, 50 watts. So it's only 46 watts coming out there. Right up to 100, 92 watts. Okay, it's not quite 100, but there's probably volts drop on the cable, and the power supply I'm using isn't the greatest in the world. So I think 92 watts is reasonable, and the difference between 92 and 100 is negligible anyway. So let's just try on 70 centimeters. We'll change sockets. On the back, go up to 433, and again we're on 5 watts to start with. So transmit 5.3 watts. Okay, that's okay. 20 watts, 45, 50 watts maximum. 49.2, just not far out. 50 watts supposed to be 49.2. That's not too bad at all. Could do a quick test on HF, but I don't really want to go through every band, because this video is going to get very boring and repetitive if I do that. So I'll just try one of the HF bands. Right, I'm on 29 megahertz. FM, 5 watts, 4.92, fine. Go up quickly. 50, 48, that's not far off. Right up to 100, 97.6, that's not too bad, is it? Okay, that's not too bad at all. Could quickly try it down the other end on 1.8, 1.8. Got to set it to FM, and 5 watts again. .6, 50 watts is 47, 100 is 96, that's not too bad. That's as good as you're going to get, I think. Okay, that's fairly successful. Could just do 6 meters, I suppose. Again, on 5 watts on FM, 5.15. 50 watts is 48. 100 is 97. That's okay. No problems at all with that. Okay, that's enough of that. I think the only final test to do really is connect it up to an aerial. Probably on 2 meters, because that's the only easy way to test it in the workshop. But I'll do that tomorrow. I've done enough today, so I'll continue tomorrow. Okay, this is the final bit of the video, and since the last time, yesterday, I got a new mat for the bench. Nice blue mat, because I thought the old yellow Formica top bench looked a bit nauseous in the videos, but so I thought I'd get myself a mat anyway. It's supposed to be an ESD safe mat. Not that that's particularly of any concern. I don't think I've ever killed anything through ESD, not to my knowledge. But anyway, final test we'll do is I'm going to access a repeater which is about 30 miles away. Excuse me. Anyway, this repeater is near Swindon, and I'm using a very basic aerial, not my normal aerial. This one's J-pole, which is only up at about 10 feet, which I'm just using for testing. So this is about the only repeater I can get into with this aerial. So I'll give it a try anyway. G6B PC, testing access WH. So as you can see, works fine. S-meter says it's S9 plus 20. That's a load of rubbish. It's more like S3 on this aerial. That's why I was saying the S-meter on FM is really fairly useless, because that wasn't even a fully quieting signal and it was saying S9 plus 20. But it worked anyway, and it got into that repeater, and I was using 50 watts. I wouldn't need to use that if I had a decent aerial connected to the radio, but that's the way it goes. So that's about the end of the video. I hope you've got something out of it. And oh yeah, before I go, if anybody wants to buy a nice TS 2000, please contact me. Bye for now.